Hey, welcome everybody to Ocean Atmosphere Climate Lesson 1.5. This is going to be pretty quick. We don't have a ton of stuff to go over here. But first, let's take a look at the warm-up. For the warm-up, you're actually going to be looking at, oh, come on, you can do it. You're going to be looking at the claims again. So, why is Christchurch, New Zealand's air temperature cooler than usual during El Nino years? Remember, this is what we had originally asked, right? What is actually going on? We know that it is cooler. We looked at that evidence, but why? What is happening? So here, to remind ourselves, is Christchurch, New Zealand. This is Australia, South America, Antarctica, etc. We are in the Pacific Ocean. And here are our claims. Claim 1, the amount of incoming energy from the sun changes. Is that why it's colder? Something about Earth's surface, the land or the water changes. Is that why it's colder? Or something about the air changes. Now, here's what we're supposed to do. We're supposed to choose the claim we think is least convincing. I think that's interesting. So which one do you think is the least convincing claim? And I want you to select it and then tell me why. Why do you think that's the least convincing claim of all three? Go ahead and do that and then come on back to me. The next thing that we're going to do is this student-to-student discussion. We're on tab number 2. Now, of course, we are not in class today, so it's kind of hard to discuss. So what I want you to do is I actually want you to take a look at the 3 different sheets and on your own, try to explain what's happening. So let's take a look at those sheets actually right now. I've attached these to your lesson. It says student number 1, number 2, number 3, but go ahead and take a look at all of them. And each one of them has a map on it, some information about temperature of 2 locations, and then asks a question. So for this one, the prompt is, why is the average air temperature of Makassar warmer than the average air temperature of Christchurch? So we can see, okay, average air temperature of Christchurch, New Zealand is 11 degrees Celsius, and this place in Indonesia, 27.5 degrees Celsius. Wow, that's pretty warm. That's extremely warm. But why? Why? Based on what we've talked about, and especially think of our lesson that we just did this week, talking about latitude and talking about the amount of energy that a place receives from the sun. Try to explain. And you don't have to write it down. We'll write some more stuff down later. But think in your head, how would you explain this to somebody? Why is the average air temperature of this location warmer than the average air temperature of this location? Here's some words for you to use. Now, there's 3 different sheets here. Take a look at each one of them. This one is Christchurch, New Zealand and Tokyo. And this final one is Christchurch, New Zealand and Reykjavik, Iceland. And it's asking questions about each one. So this one's actually asking, why is Reykjavik cooler than the average temperature of Christchurch? And again, trying to use these terms, trying to explain it, and again, think about latitude, think about energy from the sun. Go ahead and take a look at all 3 of those, see if you can explain it, and then come on back to me. We are now on tab number 3. We're moving and grooving. Now, the last tab number 2, I hope that you said something along the lines of location A is warmer than location B because it is closer to the equator. Places that are closer to the equator receive more energy from the sun and therefore have higher temperatures. Now, that's one of the things that we learned earlier this week. And we said that's the main thing that is influencing the temperature of an area is how close it is to the equator or its latitude. Remember, latitude is a measurement of how near or far something is from the equator. Where we're around 37 degrees north. So again, hopefully you said something along those lines, making that connection between how close you are to the equator, the amount of energy you get from the sun. The more energy that you're receiving from the sun, the higher the temperature. We also said that, well, there are some exceptions, aren't there? Latitude is not the only factor determining the temperature of a location, but it is the main one. All right, let's look at this. We're going to interpret some data. We have 2 graphs here. The first one is average air temperature in Christchurch, New Zealand. I'm sorry, two graphs are on the next one. We've seen this one before though. During a normal year and during an El Nino year. During a normal year, the average air temperature is 12 degrees Celsius. During an El Nino year, the average air temperature is 11 degrees Celsius. It is colder on average during El Nino years. Again, we're trying to get to we're trying to come up with a claim that's going to back up the evidence that we're seeing, or find evidence that's going to back up the claim. You know what I'm saying? So here we go. Use the first three questions to guide you as you read and annotate both graphs. When you're finished, discuss your annotations in question number 4 below with your partner. Now, you can actually put annotations on these graphs. You can click the plus button. So do that. Make annotations on the graphs. So the first question, because it says use these questions, what does each graph show? Okay. So it looks like the first graph is showing energy from the sun at Christchurch, New Zealand. Okay, great. We've talked about energy from the sun. The second graph, average ocean surface temperatures near Christchurch, New Zealand. Interesting. So these are two graphs that we have not seen before. The only graph that we've seen so far is average air temperatures. What questions do you have about the information in the graphs? Okay. If you have any questions, write those down as annotations on the graphs themselves. And then lastly, how is the evidence connected to what you've been learning about climate, temperature, and energy? I'm going to go ahead and say, why don't you pause right here, take some time to look at those graphs, analyze those graphs, and then come back to me. All right. Here's question number 4. This is down at the bottom of tab 3, button number 2. We've taken some time to look at these graphs and analyze them and see what they're saying. And the question says, do the graphs support or go against the following claims about Christchurch during El Nino years? Christchurch's air temperature is cooler than usual during El Nino years because the amount of incoming energy from the sun changes. What do we see in the graphs? Do the graphs support that? Well, we have a graph right here. It says energy from the sun at Christchurch, New Zealand during a normal year and during an El Nino year. Is there any difference in the energy that Christchurch, New Zealand receives from the sun? No, it doesn't look like there is. We may have thought that originally, like, well, it's probably receiving less energy from the sun, and that's why it's colder, but it looks like it's receiving the exact same amount of energy from the sun. So we would say claim number 1, it doesn't seem like it's supported. What about claim number 2? Something about Earth's surface, the land or the water changes. Well, average ocean surface temperatures, it looks like during an El Nino year are on average 2 degrees colder than a normal year. So it does seem like that there is some sort of change in the surface. How about claim number 3, something about the air changes? Well, we know it's colder for sure, but is there actually a change in the air? Well, I think we'll have to continue investigating to really find out if this claim is supported or rejected. But we can definitely say claim number 1 seems like it is not supported. Claim number 2 definitely seems like it is supported based on this evidence that we have right here. And claim number 3, I think we still have some investigating to do. All right, here is the last part, your homework. It is a self-assessment. Mr. Wiggin, it says it's optional. Is it optional? No, I want you to go through this and I want you to think about these things, okay? So each of these has a statement and you are saying whether or not you understand it at this point, and then explain. So for instance, the first one, scientists investigate in order to figure things out. Are you getting closer to figuring out why the air temperature in Christchurch, New Zealand is cooler in El Nino years? Do you feel like you're getting closer? If you are, tell me why. What have we discovered so far? You may want to reference the graphs that we just looked at and how they support or don't support the claims. If you're not feeling like you're understanding how energy is transferred to the air of Christchurch, New Zealand, write down what you do understand. What do you understand about energy at this point? Okay. This one too. I understand what happens to the amount of energy in the air of Christchurch in El Nino years. Well, what are we seeing? We're seeing that there's a difference in temperature. So how does that relate to a difference in energy? All right. And the third one, I understand how Christchurch's distance from the equator affects its air temperature. What have we said about latitude? How does latitude affect the temperature of a particular place? And then number 4, I understand why the ocean near Christchurch is a different temperature than we'd expect for its latitude. I don't know that we understand that yet. I don't know that we've really talked about that yet. Number 5, I understand why the ocean temperature near Christchurch changes in El Nino years and how it affects the air temperature there. Again, I don't think we've talked about that either. So if you put that you don't understand, that's fine, because we really haven't gone over anything like that. Will we? Of course we will. And then number 6, what do you still wonder about El Nino and air temperature? If you have any questions, please write them down there. If you don't have a question of what you still wonder, please just write something down that you do understand about El Nino and air temperature. Hey, after that, you're done. Hopefully that doesn't take you too long. But yeah, see you next time.